All right, so I think this is recording. Let's take a look here at number 10. We have division of two rational expressions. We want to simplify this and write it as a single rational expression and to also state any restrictions that we have. Here, our restriction with this kind of arithmetic, and we're saying that division by 0 is undefined, that we do not want any denominator to ever equal 0. And that's where we're going to start. Now with division, you actually have to do that at two separate times through the problem. You have to stop at the beginning and say, okay, what are my restrictions? Make sure that my denominators can never equal 0. And then later through the problem, you flip a fraction, which introduces a new denominator to the problem, which might introduce additional restrictions. So let's start out, however, by looking at this first fraction and factoring this denominator, this trinomial. So I'm going to come off to the side, and I've got 1a squared minus 2a minus 8. And the technique that you learned in Algebra 1 for factoring trinomials we refer to as an x method. We write the middle term at the bottom of our x, the first term times the last term up at the top of our x, and we look for two expressions that when multiplied together give us the top expression, but when added give us the bottom expression. So that might be a little bit of scratch work off to the side to think about it, but the negative 4a times the positive 2a should do the trick, because when you multiply them together you get the top expression, when you add them you get the bottom. Now with a leading coefficient of 1, with a 1 in front of that a squared, you can kind of take a shortcut now. You don't have to make a table below this x. You can just come in and use the negative 4, a minus 4. Use the positive 2. Now be careful, my a's and my 2's look very similar. So this trinomial factors to this. So let's come back to our problem. Instead of writing our denominator as a trinomial, we can write it as a minus 4 times a plus 2. And now in my second fraction, while I don't have anything to factor, I just have this a minus 5. So now, since both of my denominators we say are in factored form, it's easy for me to state my restrictions. That restriction being that I can't have either one of these denominators to equal 0. So if we look here, if a were allowed to equal 4, you'd have 4 minus 4. Well, that's 0, and anything times 0 is 0. So I have to make sure that a is never equal to 4. Negative 2 plus 2 would also be 0, and I have to make sure that a is never equal to negative 2. If I look at this second fraction, its denominator, I want to make sure it never equals 0, and 5 minus 5 gives me 0, so I want to make sure that a is not equal to 5. Alright, when I look at this first fraction now, I see that I've got a minus 4 divided by a minus 4, and I can go ahead and simplify that now. So in the numerator I have just a 1, and in the denominator I have a plus 2, and what I'm going to do now is change this division to multiplication. But to do that, I have to take the reciprocal of the divisor. I have to flip this fraction. So a minus 5 now goes up to the numerator, and this 1 comes down to the denominator. Since I have a new denominator, I'm always afraid, hey, will there be some value of a that's an additional restriction that causes this to be 0? Well, I don't have an a in the denominator. I don't have a variable in the denominator. So this time my restrictions are not. I'm not going to have to add to it. It's just going to stay the same. So now when I'm multiplying two fractions together, all I have to do is multiply the numerators together and then multiply the denominators together, and I'm done. Now, do not try to cancel these a's, because these are terms, not factors. If it was a times 5 and a times 2, then I would cancel those a's. But with addition, terms do not cancel. So we're done simplifying this problem. But unfortunately, there'll be some students that try to continue to simplify this. But that's our final answer. All right, well, I hope that helps, and I will talk to you later. Bye.